All right, over the next few days, you're going to be working on a lab where you will be trying to connect what you know about energy to what you know about topics from earlier this year in physics. And throughout all of this, you're going to be looking at the motion of a bouncy ball. So first up, if I drop my bouncy ball, one of the first things you should notice is that it loses height on each bounce. So it goes lower and lower and lower, which tells us that it's dissipating energy. Now, we know that there has to be an interaction or a force in order to dissipate some energy. And so the question you're going to be working on is, what interaction dissipates the energy? So, there are two main possible culprits. The first one is the impact with the table. And the second is the air resistance, or the air friction, as the bouncy ball is moving through the air. So, to answer this question of what's dissipating the energy, later this week, you're going to record some video of a bouncy ball bouncing, and you're going to load it into some software for a process called video analysis, where you'll be able to click on where the bouncy ball is in different frames of the video in order to produce position versus time and velocity versus time graphs. And then you're going to use those graphs to decide, is it mostly the impact with the table that dissipates energy? Is it mostly air resistance that dissipates energy? Or is it a combination of these two? Now, one of the really challenging parts of this is you're going to have to decide what you're going to look at on your velocity versus time or your position versus time graph to decide which of those two it is. And so in your green packets, if you flip to page 10, that is the start of what you'll be doing today and tomorrow. So what you're going to be doing on page 10 is you're going to assume that it's only the air resistance that dissipates energy, and you're going to sketch an interaction diagram, and then you're going to sketch a bunch of energy bar charts. On page 11, you're going to sketch a bunch of energy bar charts, but you're going to assume that it's only the impact with the table that dissipates the energy. And then if you look at pages 12 and 13, you're doing something really similar, but you're looking at the free body diagrams and the bouncy ball's acceleration. And then on pages 14 and 15, again, really similar, but you're looking at the velocity time and the position time graphs. And so these are predictions of what the representation should look like, assuming each possible explanation is true. Now, to help a little bit with that, we do have to think about where these interactions are happening. So if you look at the top of these pages, there's a sketch of the bouncy ball's path with a few different key points labeled. So one is as you're holding the bouncy ball ready to drop it. 2 is just as that bouncy ball barely reaches the table. 3 is just as it leaves the table. 4 is the top of the next bounce. And 5 is just as the bouncy ball reaches the table the next time. Now, the reason that we're choosing points just before and just after the bouncy ball leaves the table, rather than thinking about that actual impact, is it turns out it's really, really challenging to actually collect data for that moment of impact. When the bouncy ball hits the table, it compresses, which means it's going to store some spring potential energy. To deal with that, we would have to know things like the spring constant of the bouncy ball. We would have to know how much it compresses. And those are really, really hard to measure. It also turns out that impact is really fast. So it's extremely difficult to collect data during the impact. But it's not too hard to collect data just before or just after the impact. So those are the instances we're going to look at. Now, next thing I want to do is kind of break up where do those interactions actually happen. So that interaction with the air, it happens between points 1 and 2. So as it's falling, it's going to interact with the air. And then between points 3 and 4 and 4 and 5, it has that interaction with the air again. So if we're assuming that it's just the air resistance that dissipates energy, this is telling us we should see the E disk go up at points like 2, should see it go up at 4, should see it go up at 5, but we shouldn't see it go up at 3. And then that interaction with the table, that happens between points 2 and 3. So if we're assuming that it's just the table that dissipates energy, that means that from 2 to 3 is where we expect some E disk to show up, but not those other points. So this is just giving us an idea of when those interactions are happening, and therefore when we should see the E disk showing up. The other thing this does is it shows us that initial observation, that the bouncy ball loses height on each bounce, isn't going to be enough to tell us which of these two interactions is the most important for energy dissipation. Because if we go from point 1 to 4, both of these interactions happen. And so we don't have a way to decide whether it was the air resistance to the table if all we're looking at is that drop in height. Now, hopefully by the end of the day today, you'll start getting some ideas about what you could look at to decide whether it's the air resistance or the table. And what I'm looking for you to do is do the best description you can of what you think will happen. And then tomorrow we'll spend some time whiteboarding these and get ready to actually dig into doing the video analysis. All right, kick some butt with this today.